Jai Gurudev. I am Saudamini from grade 8 and today I will be presenting on the second law of thermodynamics and arrow of time. We all know the first law of thermodynamics. Energy can never be created or destroyed. Let's take a closer look at the second law. It states the total entropy of an isolated system can never decrease over a period of time and is constant if and only if all processes are reversible, and that an isolated system spontaneously evolves towards a thermodynamic equilibrium, the state of maximum entropy. I know I too prefer the first law. However, let's first take a closer look at the terms systems, equilibrium and entropy. An isolated system is a thermodynamic system which is enclosed by rigid immovable walls through which neither mass nor energy can pass through. A thermodynamic equilibrium is when the heat is equal throughout a system and to that of its surroundings. Entropy is the measure of a system's thermal energy per unit temperature, which is unavailable to do useful work as work is obtained from fixed molecular motion. Let me explain this with a simple example. In ice, the energy is concentrated in an ordered format. This energy can easily be released to do useful work. However, in water, the energy is relatively spread out and hence it's comparatively difficult to do useful work. Hence, water has higher entropy than ice. Therefore, heat doesn't pass from a body of low to high temperature without an accompanying change elsewhere, or that the entropy of the universe always increases. But there's still one thing I don't get. Why is it that the heat always moves from hot to cold and not cold to hot? Or why is it that the universe always moves towards the state of equilibrium? To understand this, let's take a closer look at this chart. Here, I have plotted the probability of a high energy atom and a relatively low energy atom exchanging energy packets or quanta. As we can see, the probability of both the atoms coming to an equilibrium is 21%, which is the highest compared to all the probabilities. But in worldly objects that have millions and millions of atoms, the probability of heat moving from hot to cold becomes 99.999%, whereas heat moving from cold to hot becomes once in a googol, which is 1 followed by 100 zeros. Thus, the second law implies that time is asymmetrical with respect to the amount of entropy in an isolated system, and hence it must always increase, though in an open system, entropy may decrease. This idea is also known as the arrow of time. Astronomers believe that if we treat the universe as an isolated system, then the entropy will always increase. Also, the arrow of time points us in the direction that our universe is heading to a heat death, as the amount of usable energy becomes negligible. Now, a mental arrow arises, as one's perception is a continuous movement from the known past to the unknown future. This phenomena has two aspects. Memory, we can remember our past but not our future. And violation, we think we can influence our future but not our past. Now that we understand, it is clear that the entropy of a system will always increase over a period of time, and we, being a part of the system, cannot do anything to change its outcome. This becomes natural to us as in the Hindu culture, there is no distinction between the past or the future, as seen in the word kal, which means one day from today, which is yesterday or tomorrow. There is no importance given to the past or future. Everything is relative to today and its happenings. This emphasizes the importance of not to distinguish much between our past and our future, as we truly have little or no control over our destiny. But surely we can mend our path over there. Thank you and Jai Gurudev.